All right, so for this lab, we are just going to reinforce some of the topics that we talked about in the last lab, and we are just going to make sure just to talk enough about regression and about strength so that when we hit the ground running in the next section, 12.3, we can really solidify that idea of strength, and you'll have a little bit of foundation knowledge of that. So if you haven't already, make sure you've done all the problems on page 123 through, I'm looking through 127. Make sure you have done all those, actually 126. Make sure you work through all those problems, and then if you have, go ahead and continue on with this video. There's nothing new in this section. This is just reviewing what we did in the last lab. All right, so again, just like the last lab, make sure you have the graph from, let's see, where is this? The graphs of the cereal. No, Amy, there we go. Oh, look how colorful that is. Oh, well, we can still use that. Make sure you have this paper handy. Okay, so looking at problem, or page 123, we have the consumer reports rating for the mean, I missed a word in there. The mean consumer reports ratings for these 77 cereals is 44. What's the largest amount of sugar per serving in a cereal that has a rating above 44? So going back to this picture, I may need to erase this because it's so colorful from last time. You know what? I think it's pretty. I'm going to leave it. I have another one right here. Just have to scroll a couple pages, just like you guys on page 127. Here we go. So it says the mean rating is 44. What's the largest amount of sugar per serving in a cereal that has a rating above 44? So this line right here is 50. And you can see where 40 is. So 44 is going to be in between. So somewhere there, and you'll notice nothing over here. There's nothing. I don't even know why I put question marks, probably because I don't know how to write nothing. There's nothing over there. So when it says what is the largest amount of sugar, sugar amounts are going to be going to the right. So what dot is farthest to the right and above the line? And so we can see this guy right here is the farthest to the right and above the line. There's nothing else. After here, nothing is over here. Okay, so that one is 7 grams of sugar. Do your papers look like this? Am I the only one that's drawing so much all over the graphs? Okay, so let's see. That was, oh yeah, I scrolled down, so we're coming back. And it says 7 grams of sugar. Perfect. All right, number 2, Consumer Reports is rating a new cereal. This cereal has 175 milligrams of sodium. Use the Scatterplots to predict. Okay, so this is why I wanted to leave all the colors on the other graph. Because if you recall from the last video, this sodium graph was just a mess. It was very far spread apart. This one had like the biggest distance between these two lines right here. This one was just a mess. We couldn't even say definitively that it went down. It's like you could even say that it goes kind of straight across the red line. But in general, it appears to have a negative effect. And so that's kind of where we left this. So now that we have recalled that from last time, I'm going to clear that out. And we want to know the cereal has 175 milligrams. So that will be right here in between 150 and 200. 75 milligrams. Would it be, what kind of rating should we put on this? Now, sometimes you might just go right here, the closest is 20, so I'm going to pick 20. But we really need to look at this overall. And so for 175, it's really everything, you know, this pen is kind of hard to see, I'll use green. It's everything from here to here, kind of this window right here, are all the dots that seem to have 175 rating. And so, yes, 20 would be an okay answer, but that's kind of a low answer. And so if we were to just assign it a rating, it's going from kind of like 20 to 60. A good way to do that is just to split the difference and say, you know what? 40 is a good number because it is as far up and down on both sides of that. 40 is right there in the middle. And so you could be vague and you could say, oh, from 20 to 60, sure, that sounds good. But if you were to be more specific, I think 40 would be a good choice to kind of average out. So we would say, I'll just write out what I just said. The graph shows anywhere from 20 to 60. This is the rate we're talking about. So 40, or maybe, so a rate, put all these words in here. So a rating, can have units with it, of 40 seems reasonable. Now that one was hard, and I don't mean hard like you don't know what I'm talking about. I think you know what I'm talking about. But it was hard in that it was hard to be specific. There are so many choices in there. In fact, any answer from 20 to 60 was a reasonable choice. If I had a problem like the sugars, I would be able to narrow it down a lot better because the sugars is closer together. It's closer to that straight line pattern. It has much better strength. So when we get into 12.3 and we really nail down the topic of strength, we'll come back and maybe revisit these or just put like a little asterisk by it and say, look at these when we talk about strength. Oh, and this is wonderful because number 3 says, does sugar or sodium give more accurate predictions? So these two we were just talking about. So this top one is going to be more accurate because everything is closer together. If I kind of follow that same pattern that I already had earlier, these dots are farther apart on the sodium graph. So if I kind of want to connect them, like that's a much bigger distance. Oh, where is it? That's a much bigger distance apart than the sugar graph. And notice this isn't an issue of any sort of scaling, because as I look on the left on the y-axis, 0, 20, 40, 60, 80, 0, 20, 40, 60, 80. It's the same scale. So when I say that the bottom numbers, the sodium numbers, are farther apart, that's an accurate comparison because they are on the same scale. Okay, so going back to question 3, does sugar or sodium give a more accurate prediction? And we say, oh man, I'll say sugar, but I'll say it in blue. Sugar is more accurate because unofficially, because the dots are closer together. That's not really the best math way to say it. I'll just put it in quotes. The dots are closer together. This is going to indicate strength. A better way is the downward trend is, I don't want you to be focused on downward. This does have a downward trend, but really the pattern, either up or down, is more clear on the sugar graph. So again, I don't care that it's downward. It could be very clearly upward and be stronger. It has to do with how close together those dots are and how clear that trend is. So when we said this red line here, when I said I want to describe these dots, you know, I'm going to clear it all out. Clear. Oh, that's not clearing anything. Okay. Clear, clear, go away. Clear, clear, go away. Okay, good. So when I say I'm going to draw a line that describes this picture, sugar line, I just standing back and looking at it without drawing anything, it looks like the dots are going down as I go from left to right. So I could draw a line that goes down. The sodium dots are a mess. So if you're only allowed to draw one straight line to describe that pattern, does it go down? Does it go straight across? Like, what does that line look like? And so it's not really clear if that was good. Maybe the line was supposed to actually be like that. I don't know. It's not clear. And so that's what I'm talking about on number 3. When I say the dots are closer together, that's the more mathematical picture version of what I'm talking about. The downward trend is more clear on the sugar graph. If you are feeling a little vague on this and you're like, how can you tell if the downward trend is clear? Or what do you mean it's stronger? Don't even worry about it. That's what 12.3 is about. We will have actual numbers to attach to this. We will make it very clear. We will have some formulas. You might have seen the 12.1 lecture already, and you've already seen kind of the idea of the formulas. We're going to make it much more detailed. Again, I'm just kind of laying the foundation for strength, and so we will fine tune that in the next section. Okay, so here we have a graph of fat versus sugar. So it says this gal is talking about what she eats, that she's concerned. She pays attention to sugar, but is also concerned about fat. She believes low sugar indicates low fat and high sugar indicates high fat. Does the picture back it up? So ignoring this picture for a second, if I was to draw what she said, and I have sugar here and fat here, what is she talking about? Well, she says low sugar means low fat and high sugar means high fat. So if what she's saying is true, I should be able to see some sort of upward pattern on this picture. So do you see an upward pattern? Does the picture look like that red line there? And I would say no. Even if I drew it less steep, let's say I drew it right here. No, that doesn't look anything like that line. I have so many dots, all these dots down here. I have so many dots up here. It just looks like a whole bunch of dots all over the place. This looks more like my kids spilled pepper on the table. That's what it looks like. It does not look like any sort of straight line. So I'm going to say, oh, where am I going to say it? Oh, I guess I'll just say it right here. I'm going to say, no, this does not, does the pattern your friend describes appear to be true? No. The pattern described is not true, according to the picture, according to the scatter plot. Oops. Scatter. And then fill in any extra words that help you understand this picture. These dots do not follow a line up. Now, up is what I was focusing on because that's what the gal was saying. She was saying low fat, low sugar, high fat, high sugar. You could say, well, what if it was backwards? What if it's actually a pattern, but it's just going down? Try it out. Nope, those dots aren't anywhere close to that line. There is no pattern, just a mess that we see. So the pattern described is not true according to the scatter plot. All right, next up we have if a Major League Baseball player gets more hits, will the player also get more home runs? So we have a table listing the number of hits versus the number of home runs. And so first up, we're going to draw this scatter plot. All right, so I have, and again, we're just going to be estimating this. Just draw a big dot. If, you know, the bigger the dot, the more ishy-ish it can be. So 119, 5, 6, 7. 119 is like right there. And then 128 and 12. Okay, I'm actually gonna pause this video and just draw it because y'all don't need to watch me drawing a picture. All right, and through the magic of technology, we are back and I have a picture for you. And this is just a great reminder that I can pause anytime to throw some problems up to make it, or throw these dots up to make it go a little faster for you. And you can pause at any time to look over a problem and make it a little slower for you. So that's what's so great about these recordings is I'm sure if you really wanted, you could put me on like ×2 out there and get these lectures done twice as fast. But then I'd be talking like a little chipmunk, so I don't know if that would be a great idea. Okay, sorry, I'm just having way too much fun with this. Okay, here's my scatter plot. We're almost done. What does each dot represent? Well, let's go back to the table. Here I have the number of hits, the number of home runs from someone, some player. These are by professional baseball players. And so each dot represents each person's number of hits to their number of home runs. So a dot represents a baseball player. Based on the scatter plot, should you use the number of hits a player gets to predict the number of home runs a player will get? Explain how the scatter plot supports the answer. In other words, good or bad, up or down, is there a clear pattern? So what I like to do is I like to draw a line. I don't know, because these guys are pretty far away from that line. So I don't know that that is necessarily clearly up. Let's try down. Oops, I'm trying to erase the red without erasing the blue, but it's just not happening today. There we go. Okay, so let's try drawing it down. Does that line describe the dots? Ugh. I would say not really. I mean, if they're both kind of, maybe sort of, then it's neither, because it can't be both. So if you're feeling like I can't make a clear decision either way, then the answer is neither. And so what we're just saying here is based on the scatter plot, the number of hits is not a good predictor. Oops. Is that supposed to be an O? Predictor of the number of home runs. Yeah, no clear pattern. We got a lot of no's, so let me just draw a picture of what a yes would look like. Oops, that supposed to look like a snake. That is an upward pattern. The dots all go up. They go up at different paces, but they go up. So this is positive linear association. This one over here, a bunch of dots all over the place, but it's going down, and overall we see a negative linear association. So those two have clear patterns. This picture does not have a clear pattern. It kind of started off with a clear pattern. It's like, oh, it looks like it, but then it kind of spazzes out there at the end. So it's not clear, so we just say no. All right, let's see. I think that's it. Yep, we're at our supplement. So we are done with 12.1, and I will see you in 12.3.